We are looking at Chapter 2, Test Yourself, on page 98 of the textbook. We are going to go do all the questions one by one to see, just so that you have some reference of how to do it. So it says, how many orders of faces are possible when a standard die is rolled? That's question 1. And essentially what you got to do is you roll it 4 times. And how many different outcomes are there here? It's 6. The second time you roll it, there's 6. There's 6 outcomes, and there's 6 outcomes. Now, when I do my tree diagram, and you can skip ahead if this is obvious, that it's 6 times 6 times 6 times 6, or 6 to the power of 4. If that's obvious, you can skip this little example right here where I do the tree diagram where there's 6 branches. Now, for every one of these branches, I'm going to branch out 1, 2, 3, 4, 5, 6 times for the second row. 1, 2, 3, 4, 5, 6. And every one of these, I'm going to branch out another 6 times, right? So for each available outcome, 1, 2, 3, 4, 5, and 6. And we do that 4 times. So for every one of these, there's another 6. So that's why it multiplies. It basically multiplies by 6. So 6 to the power of 4 is 6 to the power of 4. Is 1296. So the answer is C in this case. Moving on to question 2. Which of the following is equivalent, we're not going to write out the question, to P101, choose 98. 101, choose 98. Okay, so essentially what that means that it's the same thing as 101. The formula is, by the way, that's equal to n factorial, or PNR is equal to n factorial over n minus r factorial. So if n is 101 and r is 98, then that's equal to 101 factorial divided by 101 minus 98 factorial, which is equal to 101 factorial over 3 factorial. Do we see that anywhere there? Yes, we see it at D. Okay. Next, so basically what this means is that, we're going to do 101 and 98 numbers being multiplied here. So we're choosing 98. Okay, next is, when flipping a coin 5 times, what is the probability that heads turns up every time? This is question 3. So if A is defined as flipping heads 5 times out of 5 flips. Well, how many ways can we do that? Well, there's only one way to do that. How many possible outcomes are there? Well, this, once again, we'll do the tree diagram, but for each one of these, I could go heads, tails on the next flip. By the way, the second flip could be heads, tails, and there's 4. And for each one of these 4, there's heads, tails, etc., etc., right? Heads, tails. Each one of these has 2. So it's like the first flip, there's 4 flips, and I know there's 2 possible scenarios for each one. So the answer is 2 to the power of 4, which is 2 to the power of 4, 2 times 2 times 2 times 2, which is 16 possible outcomes. So the probability of flipping heads 4 times, by the way, where does it exist here? Only one of them exists, right? Where I get heads in a row. So probability of A is 1 over 16, which is the same thing as, that's 1 and that's 16. It's basically NA over NS, just to be overly formal. Okay, which of the following is not defined? Let's check this out. Okay, if I have P, 12, choose 8. I mean, that's just saying that's 12 times 11 times 10 times, and 8 of these, right? Or 12 factorial over 12 minus 8 factorial. Seems right. P9, choose 10. Now, here we have 9 factorial over 9 minus 10 factorial, which is 9 factorial over minus 1 factorial, which is not defined. So the answer to this question is P9, choose 10. Okay? P7, choose 0 is defined, and P100, choose 100. There's only one way to not choose 0 and one way to choose everything. Okay? I believe that's true. Let's see. I believe, yes, that is the case. Now we move on to the short answer question. It says, Rosa is getting dressed and has decided that her shirt, pants, and socks are not to be the same color. She has red, green, black, and blue of each. Draw a tree diagram illustrating her choices. Oh boy. So we have tree diagram. And we're talking about Rosa is getting dressed and has decided that her shirt, pants, and socks. So she has a choice for shirts, right? And she has red, green, black, and blue. Oh, shoot, there's 4 of each. So red, green, black, and blue for L. I hate when they use the same letter for both. Okay, and if she picks a red shirt, well, what does she have to pick next? Rosa has to pick pants. Pants, red. Oh, because she picked red, she doesn't want to do red no more. So green, black, and blue. And if she picks green, she chooses green. Oops, she can't choose green. She has to choose red, black, or blue. And if she chooses black, she has to choose red, green, or blue. And if she chooses blue, she has to choose red, green, or black. And finally, for a shirt, let's see. Shirt, pants, socks. Well, if she has red and green, she has blue, black or blue to choose. If she chooses black, she has green or blue to wear. And if she chooses blue, she has green and blue to wear. If she chooses red, and the way I'm doing it is I'm just using the other two and just marking them. So I have red. That means I can wear blue black or blue. If I'm black, if I wore black pants and green shirt, I can wear red or blue. If I'm blue, etc., etc. So as you can see, if we look at the choices, there's 2 choices for every one of these. And there's 3 choices. I'm not going to do the whole thing. I mean, you can do it for practice. But we have 3 choices, 2 choices. We had 4, 3, and then we have 2 choices for each of these. Right? And essentially it's 4. If we want to look at how many choices we get ahead of ourselves, we have 4 total choices over here. Multiply it by 3 to get the number of choices we have over here. Each one of these choices has 3, so that's 12 choices. And every one of these has 2. Right? So, essentially, how many choices does she have if she starts with a red pair of pants? Okay, so if she starts with a red pair of pants, let's get rid of some of the markings we just did. Essentially, if she just has a red pair of pants, if I start with, well, I can rearrange this to say pants, shirt, and sock, right? Well, essentially what that means is if I choose my red pair of pants, I have 3. I just have to choose my shirts, and I have 3 choices there, and socks, and I have 2 choices there, so 3 times 2, which is 1, 2, 3, 4, 5, 6. 6 possible choices. Okay, and that's how number 5 is done. It says a hockey team, question 6. A hockey team has 4 left wingers, 4 left wings, 3 right wings, 4 centers, and 3 left defense, and 4 right defense, and 2 goalies. Okay. To create a starting lineup, a coach needs 1 player in each position. How many ways could this starting lineup be chosen? So, obviously, positioning matters, right? So, I have a choice for each of these. How many choices do I have for left wing? 4 times 3. For every one of these choices, I have 3 choices of right wing. And for each one of those, I got 4 centers, right? So, I have 12 of these. 12 combinations. For every 12 of these combinations, I have 4. They could go with 4 centers. So 12 times 4 equals 48. I have 3 right wingers, or left defense, so 48 times 3. And I have 4 choices here and 2 choices there. So you multiply all of these, right? 48, what's this? 12, 48 plus times 24, which is, do the math real quick on a separate calculator. You have 48 times 24 is equal to 1,152 should be your answer. Next, question 7. How many ways are there to assign 5 different roles in a play to 12 members of a drama club? How many ways are there to assign 5 different roles in a play to 12 members in a drama club? Well, that's easy. We have 12 members. We're going to choose 5 of them. So that's 12 factorial over 12 minus 5 factorial, which is equal to 12 over 7 factorial, which means that's 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 factorial, right? 7 times 3 times 2 times 1. We cross that out, and we end up getting, we'll do the math right now. 12 times 11 times 10 times 9 times 8, which is equal to 95040. Okay? And you could just put this into your calculator. 8. There are 3 Canadians in the finals at the ski competition. So, 3 Canadians. Finals. Assuming all 8 competitors are equally likely to win, what is the probability that 3 Canadians will win gold, silver, and bronze? And how many are there? There are 3 Canadians. And what's the probability that 3 Canadians will win? Well, how many ways are there to arrange my... Well, let's just do this math first. So, what's the probability? How many ways can they be chosen? I guess the question is, we need to find out NS and NA to find PA, which is equal to NA over NS. Now, let's say they're equally likely to win. We have NS, total ways to count, is basically we have 8, choose 3 ways, right? So that's equal to 8 times 7 times 6, which is equal to 336. NS equals 336. What is A, by the way? we have to define A as Canadians winning finals. So how many ways can that happen? First, second, and third. Well, the answer is 3 factorial, right? Because if this is gold, silver, and this is bronze, if one of them takes, you have 3 choices for gold, 3 choices for silver. Now this 36 Na equals 6. So probability of A happening is equal to 6 over 336. Or 1 over 56, which is about 17.9%. Okay, let's move on to, we did question 8. Let's move on to question 9. How many arrangements are there of the letters in the word computer? So we have C-O-M, so far no repeats, P-U-T-E-R. Oh, that's easy. So how can we arrange that? Well, how many letters do we have? 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 letters. 1, 2, 3, 4, 5, 6, 7, and 8. We have 8 choices for the first. Once we use a letter, we only have 7 choices, times 6, times 5, times 4, times 3, times 2, times 1. Basically, 8 factorial ways to arrange them. Now, what if I can only begin with a consonant? That's 1, 2, 3, 4, 5. I have 5 choices. So for my first, this all changes, right? By the way, what is 8 factorial? 8 factorial is 4320. That's the answer to A, 9A. 9B is a little different. And we'll do 9B. Let's do 9B in the following way. Duplicate. And I just want to make some erase marks. Whoops. Okay. Essentially, it's almost the same. Except the first one, I only have consonants. 1, 2, 3, 4, 5. 5 choices. And once we've made 5 choices, I have 7 times 6 times 5 times 4 times 3 times 2 times 1 ways to do it. So it's essentially 5 times 7 factorial, which is equal to 7 factorial times 5 equals 25,200. Should be our answer. Number 10. In how many ways could 11 members of a soccer team line up if the captain and assistant captain must remain apart? Okay, this one's a little bit tricky. So we have 11 members of a soccer team. In fact, yeah, let's just draw it. I'm not going to be fancy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, there's so many ways that they could be apart. They could be 1 apart. I mean, that's not apart. They could be 1 apart. They could be 2 apart, 3 apart, 4 apart. You know, they could be 4 apart here. There's so many different ways that they could be apart. But there's not that many ways they can be together. There's less ways that they can be together. So we have to use the indirect method here. In that, we have to calculate how many total ways are there to arrange. Well, there's 11 factorial ways. Total ways to arrange n of s, total ways to arrange 11 players is 11 factorial. How many ways were there together? How many ways were there together? Well, when they're together, the trick is to count them as one, right? So if they have to be up together, then we essentially count one of these as one. And now, in this case, we have 10 choices, 9, 8, 7. Well, we have 6 choices of where to keep this one. 6, 5, 4, 3, 2. Uh-oh. Did I get 11 here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, there we go. 11. And one choice there. Right? So it's almost like you have 10 factorial, where they're together. And then there's 2 factorial ways to arrange, or two ways to arrange the way these are arranged. So for every combination, depending on where this goes, it could go here, it could go there. But even within that, these two can be switched. So that's where the 2 factorial comes from. So that's with them together, right? Number of ways they're together is 10 factorial times 2 factorial. Let's erase that. So then the number of ways they're apart is equal to 11 factorial, total ways that you can arrange, take away number of ways they are together. Whoops. And that's equal to, well, what's 11 factorial? 11 factorial is equal to 39,916,800. Take away 10 factorial, 3,628,800 times 2. Well, times 2 factorial. And that's equal to, well, I'll just do the math. 11 factorial, take away, open brackets. You guys can't see this. 10 factorial times 2, close brackets, equals, the answer is equal to 32,659,200. Okay. In how many ways could 11 members of a soccer team? Okay, so that's the answer to number 10. 11. There are 25 men and 20 women who belong to a club. An executive panel consisting of president. So now we're creating a club, right? So these are questions we've seen. Vice president, secretary, and treasurer be chosen. Okay. In how many ways could the executive panels be chosen with no restrictions? Well, I have, let's see, 45 people. It's basically 45 choose, what's it called? 4, right? So it's 45 factorial over 41 factorial. So 45 factorial divided by 41 factorial equals, the answer is 3,575,880, right? So that's A. What about B? B says, in how many ways could an executive panel be chosen if it must include at least one woman and one man? Okay, so yikes, I forgot how to do this. So let's think about this for a second. Well, think about it like this. For president, it doesn't say that I have to make the president, right? I have to include at least, it says must include at least one woman and one man. Okay. So the way I would do this is, actually, I got it. I'll use the indirect methods. So this is the total number of ways, right? And I'll call this NS. So how many ways if there's no men? No men. Well, if there's no men, and they're all women, we're using all women. There's 20. The answer is 20. Choose 4. And if there's no woman, well, there's 25 men. Choose 4. Okay? So, and how does the question say? At least one woman and one man. So we're going to subtract all the ways there's no woman and all the ways there's no men. And that way we know that there's at least one woman or one man on the committee. So the answer is, to this question is, so B is P, 45, choose 4. Take away 20, choose 4. Take away 25, choose 4. And let's see what that equals to. That's equal to 20 times 19 times 18 times 17. And that's take away 11, 116, 280. I got that from there. And that's 25 times 24 times 23 times 22. And that's equal to 303,600. And that's equal to 3,575, 880. So, and you got to think about it like this. If this is all committees, and this is no man committees, and this is no woman committees, basically all man, right? So they're not going to hit. So we subtract them. Make sense? Okay, C. In how many ways could the executive panel be chosen if the president and vice president must have different genders? Okay, so what would we have? President, vice president, secretary, and treasurer. Okay, you must have different genders. So if I choose, how many of them do I have? Right? So case 1, you have to do cases. Case 1, P, let's just say male, according to the men, according to this question. Okay, so what do we have here? We have how many choices for men? 25, and then after I select, this has to be 20. Okay? And then how many choices do I have? Well, they could be anything. So it's 45 minus 2 that I already chose, so 43, and this one can be 42. Okay, so it's case 1 is 25 times 20 times 43 times 42. Case 2, president is a woman. So we got P, VP, S, and T. And if it's a woman, we have 20 possible women, 25 VPs, and same thing here, 43 times 42. So the number of ways is 20 times 25 times 43 times 42, which is exactly the same thing as that. So we just add them, or multiply this by 2. And that's your answer. We have both cases, and we multiply by 2. Okay, let's look at question 12. Almost at the finish line. 4 letters are randomly selected from the alphabet. What is the probability that they are A, B, C, and D in that order, if repetition is permitted? Okay, so it's asking about probability. Probability of A. A is defined as A, B, C, and D are selected. Honestly, only one way that can happen. So N of A is equal to 1. N of S will depend repetition is permitted? Well, I have 4 letters, 26 for each. So P of A, if repetition is allowed, right, is equal to 1 over 26 to the power of 4. You can do the math on that one. And then B should be, if it's not permitted, well, if it's not permitted, it's almost the same as that. Duplicate, except with one small thing. I can't repeat my letters, so there's only 25, 24, 23, or P, 26, choose 4. Possible permutations, okay? So P of A would equal to 1 over P, 26, choose 4. You can do the math on that. Next, 10 people, 13. 10 people each randomly select a number between 1 and 20. What is the probability that at least 2 of them select the same number? So this is exactly like the birthday question, because if one person selects a number, then the next person, is more likely to get, you have 1 in 10 chances. But if I miss, then I have 2 in 10 chances. So every time someone misses, the next person to select the same number, the chances increase because there's that many more people. Okay, so 10 people, and I explained this in class, but I might as well explain it today, right? So I have 20 numbers, right? So let's assume they all miss, right? So these are my numbers. There's 20 spots. One person selects a number. What's the probability that that person gets it? It's 1 out of 20. The next person, right? 1 out of 20. Person 2. Person 3, assuming that they don't match. Now, person 2, assuming person 2 doesn't get it, that means 2. So think of it as a target. Person 3 now has 2 out of 20 to choose from. Person 4 has 3 out of 20 chances to get it. If person 4 misses, if person 4 misses, then there's 4 out of 20 chances to get it. See how the target keeps getting bigger? After I get the 5th person chooses, what's the chances of them not getting it? By the time I get to 10 people, now I've gotten to 8 people, it's very likely that I'm going to get it, right? So what's the chances of missing twice? Well, it becomes even smaller, right? So each time I miss, the chances of success hitting the same number or place increases. Okay, so that's like the birthday question. So how did we solve the birthday question? Well, we said at least 2 of them select the same number. So 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10 of them select the same number, right? We have to calculate the probability that none of them get the same number. What's the probability? We can't have one person getting the same number. What's the probability that none get same number? And the way we do that is, well, probability of, A is none get the same number. Probability of A equals NA over N of S. How many different permutations of numbers could they be? Could they all get the same number? NS is probably equal to 20 choices to the power of 10 people, right? But NA is, they can't share the same birthday. They can't share the same number. None of them get the same. So the first person, how many choices does the first person have? 20. But then there's 19, then there's 18. Essentially, it's going to be 20, choose 10. And that's the answer. So that's a probability of none get the same number. So all you have to do is P of not A is equal to 1 minus P of A. Whatever this ends up being, you just subtract 1 from it, and that's your answer. Okay, I'm not going to do the math because I don't have a scientific calculator on me at the moment, but you can figure that out. To determine who should be, question 14, final question. Determine who should be the first dealer in a card game. One card is dealt to each of 5 players. The player with the card of the highest denomination gets to deal first. Whoa, let's read that again. To determine who should be the first dealer in a card game, one card is dealt to each of 5 players. So I have 5 players, 1 card is dealt, and I'm assuming it's a regular card game. How many different results are possible when dealing to 5 players? Well, 52, 51. Basically, it's 52, choose 5. In how many ways could all the players receive cards of different denominations? What does that mean? Aren't they all different? Oh, denominations. They're talking about 1, 2, 3, 4. So, that's funny. In how many ways? Okay, so essentially, you have 5 players. You want them to be different denominations. So the first one has 13, 12, 10, 9, and 8, which is essentially, this is B, 13, choose 4. What is the probability that 4 players receive cards of the same denomination? Oh my god, that 4 people receive cards of the same denomination? Okay, well, the probability of that happening, we have to find out A. A is 4 players get same denomination. So how do you do that? Let's see. 4 players get the same denomination. Which 4 players? That's the question. Okay, so the way I would do it is I would say I have my 4 players, and they all get the same denomination. So I would say there's 4 to choose from, then 3, then 2 cards to choose from, then 1. And then after that, you have 48 cards to choose from. But that doesn't include the fact that of who gets those cards, right? Let's think about that for a second. I believe it's 4 times 3 times 2 times 1 times 48 is the answer. Is NA. And NS, of course, is 52, choose 5. Okay, let's discuss this question in class. I'll look over that in a second in more detail, but we'll discuss that in class. If you're watching this, ask me about it in class. How would the solution to part C change if the players chose a card from the full deck instead of being dealt once? Well, you'd have 4, 4, 4, 4 times 48. But then I have to think about the number of ways that... No, not even. 52. How would the solution change if the players chose a card from a full deck instead of being dealt one? Oh, okay, so it's basically 4, 4, 4, 4, and 52. And to be honest, that's not right, actually, because the first one would be 52. Okay, let's save this 14C for more class discussion at a later date.